Hello dear students, welcome back to our Science GK Facts YouTube channel. When I came across few students of class 10th, they expressed their difficulties in science, especially the lessons such as light. The easiest topic, that is light, they are finding it difficult. What is the problem then? Let us try to analyze the lesson in this lecture. If you have difficulty, you can express me later. Okay, let us come to the lesson. In this lesson, we are going to deal with the ray nature of light. Light can exhibit wave nature, particle nature and ray nature. In this lesson, just we are dealing with only ray nature of the light. Ray properties we are studying here. In the lesson, mainly we are dividing the whole lesson into two topics. One is related to reflection, the other part is related to refraction. Then first we need to understand what is reflection of light. As you already studied in the previous class, let us try to redefine that once again. What is reflection? Now, this is a line. If I show here these lines down, this denotes rough surface and this upper line denotes polished surface. This is polished surface. When we throw a ball on the ground on a hard surface, if the ball is made up of rubber, it bounces back, right? It must bounce back. In the same way, on this polished surface, when we leave the light rays, it bounces back. This bouncing back of light rays from a polished surface is called reflection of light, as we have already know this one. Now, let us try to imagine an imaginary line at this point which is perpendicular to this polished surface. This line we call it as normal, and this you can consider it as mirror. This upper line denotes polished surface and down lines, these denote rough surface. Then we can consider this as a mirror. It may be a mirror or any polished surface. On that, when the light rays are incident, when we make them to fall on that surface, they bounce back from that surface. This phenomenon is called reflection of light, as you have already studied. Now, coming to few concepts related to this reflection, that is laws of reflection. Let us try to analyze what is laws of reflection here. First law of reflection, it says when you leave a light ray on a polished surface, it bounces back and it is going in another direction. When you imagine a line which is perpendicular to this polished surface, this is called normal. Now, this ray which is falling on that polished surface is called incident ray. We call this as incident ray. Incident ray. And the ray which is bouncing back after reflection, that is called reflected ray. We call this as reflected ray, right? Okay. Now, this incident ray is making an angle with this vertical, means perpendicular line. What we are calling this as normal. The angle made by this incident ray with the normal is called angle of incidence. This is called angle of incidence, right? Now, here, when that light ray is bounced back, it is again making an angle with this normal. This angle made by this reflected ray with the normal is called angle of reflection. We call this as angle of reflection, right? Now you understood what are these angle of reflection, what is angle of incidence, what is incident ray, what is reflected ray. Now we have to come to know what are the laws of reflection. Coming to laws of reflection, the first law says the angle of incidence is always equal to the angle of reflection. Means when a ray of light is incident on a polished surface, it is making an angle with this normal. This angle will be exactly equal to the angle made by that reflected ray with the normal. That is, angle of incidence is always equal to the angle of reflection. This is just first law of reflection. Coming to the second law of reflection, what does it say? Just it says the incident ray, the normal at the point of incidence. This point is called point of incidence. The incident ray, the normal at the point of incidence, and the reflected ray. This reflected ray, all these, they are lying in the same plane. Means what does it say? The incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. In the same planes, and in this, it means what? See, just if I show these fingers, all the fingers are in the same plane now. If any finger is out, then it cannot be in the same plane. So all these lines, they are coming in the same plane. Means this incident ray, reflected ray, and normal, they are coming in the same plane. Means I can draw them on the board. No ray is coming out of that or going behind the board, right? They are in the same plane. This is second law of reflection. Now coming to plane mirror. We are very much familiar with plane mirror already because we will be looking into that mirror ourselves most of the times, right? While getting ready. Now coming to plane mirror, what are the properties of images formed by a plane mirror? That we need to understand them. Very simple. You don't need to buy at all these things. Just you stand in front of a plane mirror and just look at yourselves. How does it look? That plane mirror in the image. Size of the image you see and size of your body you see. Size of the object means who is standing in front of the mirror, that is called object. And what that reflection we are seeing inside that mirror, that is called image, right? When we are standing in front of the mirror, we will be the object. When we look into the mirror, we find ourselves into the mirror, right? You consider the size of your body and size of that image that you are seeing into the mirror. Both are of same size or not? Simple it is. Okay. So what we can say, the first property is the image formed in a plane mirror is same size as that of the object. Means object size and image size both are same. This is first property, right? Second property, when you are standing in front of the mirror, how are you looking there into that? You are looking straight. When we are looking as we are, that is, image is erect. Erect means same as it is. If it is looking upside down, then it is called inverted. That is called inverted image. For example, see, this is the candle. This is, we can say this as erect one now. Inverted image means we can find the same image like this. Mirrors will form these types of images. In further topics we will come to know about that. This is erect, this is inverted, right? So what we can say, object size and image size both are same. The image is erect in the plane mirror. Next, virtual and real, two types of images we find there. Virtual means you can find your image into the mirror, but you cannot get that image out of the screen, means out of that mirror onto the screen there. You cannot get it on a screen, but you can see it in the mirror. Then you can call this as what? Virtual image you can say. Real means what? Just you have seen that projectors, right? When that image is cast on a screen there, we can find that pictures coming onto the screen. That will be a real image, right? If the image is coming out of that mirror, that will be a real one. If you can see the image into the mirror but not getting on a screen, that is called virtual image. So what we can say, the image is erect, it is virtual and same size as that of the object. Okay? 3 points we learned. Next, when you are standing in front of the plane mirror, just you stand at a distance of 1 meter and just move 2 steps backward. what happens to the image that you are seeing into the mirror? That image, that will also move back 2 steps, right? If you come 1 step forward, that will also come one step forward. Means what? The distance of the object in front of the mirror is same as that of the distance of the image behind the mirror. For example, if this is the mirror, if this is the object, what distance it is? If it is 1 meter, then the image found by this, that will also be 1 meter behind the mirror. This will also be 1 meter. See these properties. 4 points we learned, right? It is virtual, erect, same size as that of the object image. Next, distance of the object and distance of the image, both are same from the mirror, right? This we learned. Last point is what we find when we are doing some work with, if you are writing with right hand, when you look into the mirror, it looks like you are writing with left hand, right? Means what does it say? That is called again inversion. What type of inversion it is? Lateral inversion. Lateral inversion means side to side. It is looking opposite there. Your right hand looks left hand into the mirror. This is called lateral inversion. All these characters or natures we can find the images in the images formed by a plane mirror, right? We just learnt about plane mirror. This is over. Now we are coming to the actual topic of class 10th, that is most interesting one, that is dealing with spherical mirrors. Then what are spherical mirrors then? Spherical mirrors means very simple it is. The mirrors which are spherical, they are spherical mirrors we can say. But how do we define this then? Very simple. The mirrors whose reflecting surface is curved. If this is the mirror whose reflecting surface is curved, then we can call this as spherical mirror. When do we call this spherical mirror? Because we are considering this mirror as the part of the sphere. That is why we are calling it as spherical mirror, right? Because from the part of the sphere it is formed, like that we are imagining, and we are constructing those mirrors in the same way. Because of that we are calling them as spherical mirrors. There are two types of spherical mirrors that we have to study in detail. First one we are going to learn, that is concave mirror. First one is concave mirror. So let us remove this. Now we are going to learn few terms related to these spherical mirrors, right? First one, let us try to understand about concave mirror. Now coming to concave mirror, look at this mirror what I am drawing here. This with lines what I am showing, this is rough surface, and this single line it is called polished surface. I am calling this as concave mirror. Concave mirror means what? We can see our image from this side. Image is formed from this side. Okay. This side is rough surface. We cannot find any image on this side, right? Now this is the reflecting surface of this mirror. It is whether it is curved inwards or not. So the mirror, a spherical mirror whose reflecting surface is curved inwards, is called a concave mirror. This is curved inwards, so that is why this is called concave mirror. Now coming to this concave mirror, we have to learn some of the terms. Okay, what is that? You take this concave mirror. This is the concave mirror. I am holding it like this, say for example. Now what I will do here, if I put a drop of water on this mirror, just it slides down and settles here, right? This drop of water. This is center of that curved surface or not? That center of that curved surface we call it as pole of the mirror. Okay, this is pole of the mirror. Now one more mirror let us consider. Now consider this mirror. I am showing these lines on the right side and polished surface is this side. Now This is also a spherical mirror whose curved surface is, what is that? It is bulged outwards. Okay, it is curved outwards. Like this we can see. Then we can call this as a convex mirror. This is convex mirror. Now, see. This is concave mirror. This is convex mirror. Now you see, this is part of a sphere, right? This concave mirror is part of a sphere now. If you extend this sphere in the form, this curved line in the form of a sphere, you are getting a sphere, right? This is a sphere. Then this concave mirror is a part of a sphere. Now this sphere has a center or not? This has a center. Okay. This center, it is called the center of curvature. This is curve. Okay, this is curve. This is center of this curve. So that is why this is called center of curvature of that concave mirror, we can say here. Now, this is center of curvature. Here, in case of convex mirror, if you extend this line, if you continue this line, again this will also form a sphere, right? Now, this sphere also has a center. Then, this center is also called a center of curvature. This is curvature, this is center, it is center of curvature, we can call this one, right? Now, here also, this mirror also has a central point here on its surface. This is called pole of the mirror. We understood what is center of curvature, what is pole of the mirror, we understood. Now you see, if you imagine an imaginary line passing through this horizontal imaginary line passing through this center of curvature and pole of the mirror. If you imagine this imaginary line, it is called principal axis. We call this as principal axis. Principal axis we call for this, right? Now you see, let us remove this remaining part because we have to keep it as just mirror. It is part of the sphere that we know already now. Now you see, an imaginary line passing through the center of curvature and the pole is called principal axis. We call this as. And in case of convex mirror also, if you imagine an imaginary line passing through this pole and the center of curvature, this line is called again principal axis. Right? Now you have to see the distance between the center of curvature and pole of the mirror. What is this? Very simple. This is curvature, it's the center it is. Then from center to this perimeter, what we can call this one? That is circumference of the circle, we can see otherwise, right? This from here to here, this distance will be what? Radius or not? Simple, right? Since it is radius, we can call this as radius of curvature and we denoted this by a letter R. This is radius of curvature. The distance between center of curvature and pole of the mirror is called radius of curvature. Here also in case of convex mirror, the distance between pole and center of curvature is called radius of curvature. Right? Now, here same concave mirror will take. This is the concave mirror. What I'll do, I'll focus it towards the sun and I'll hold a sheet of paper here. If I hold a sheet of paper, when I focus that sunlight on the paper, you have to see the light rays, they converge at a point. A bright spot we observe on the paper immediately starts, it catches fire there. It starts burning. Means what? Whole sunlight, means rays of sunlight, they are coming parallelly. When they are converged on the paper, piece of paper, it is making a bright spot here. When this sunlight is concentrated at a point, it starts getting heated up and it catches fire immediately, right? Now you have to see all these rays which are coming parallelly on the principal axis, they are meeting at a point, right? Now you take this in another way. See, this is the concave mirror, right? The rays which are coming parallelly, this is principal axis, as you know already. Now we have learned this, right? After, when we are reflecting this one with the help of a concave mirror, they meet at a point on the principal axis, right? Where these rays are converging, that is called focal point or principal focus. We call this as principal focus. We call this as center of curvature, right? Now, as you know already, distance between center of curvature and pole is called radius of curvature, of course, that is right. But these parallel rays where they are meeting on the principal axis, this point is called principal focus. We call this as principal focus, right? Now, if you take here, we are considering this concave mirror, the diameter is there here from one end to another end of this mirror. This diameter we call it as aperture of the mirror there. We are considering the mirrors of small aperture as compared to radius of curvature. Only such mirrors we are considering. When we consider such mirrors, there is one rule. What is that? That rule says, when you use the mirrors of small aperture, then principal focus, this is principal focus, the distance between this principal focus and pole of the mirror, that is called focal length. We call this as focal length, this distance from here to here, and it is denoted by f. We call this as focal length and it is denoted by f. See, we are calling this as f here. Total distance from here to here, r, right? As we have studied, is correct. That is pole. Okay, you can consider this as pole. See, this distance from here to here. Usually we are taking this distance from center of curvature to pole. Only on the principal axis we are considering, not out of that principal axis, radius of curvature. Okay, you keep it remembered. Just to, in order to show that focal point, I have shifted it upward, right? Now, the distance between this principal focus and the pole of the mirror, that is called focal length. Okay, and this point is called principal focus. Now you have to observe two properties here in case of concave mirror, in case of convex mirror. Here, in case of concave mirror, the focal point, that is principal focus and center of curvature, both are in front of the mirror, right? Whereas in case of convex mirror, here you can observe these rays, after they are incident, they appear to diverge. Okay, they appear to diverge, but divergence comes from this divergence. It is coming from a point on the principal axis. Again, this will be what a principal focus. We'll shift this side, center of curvature. Now again, the distance between pole of the mirror and the principal focus, that is called again focal length. Now the distance of this radius of curvature, if you consider this radius of curvature, its length will be double the length of principal focus. Means what? Focal length how much is there, radius of curvature will be double. Means r by 2 will be equal to f, right? Otherwise radius of curvature will be 2 times of f. What you are taking here focal length, it will be half of the radius of curvature, or radius of curvature will be double the length of focal length, you can say. Now you can consider here, you should not mix up everything. Let us remove this. Now in case of concave mirror, the principal focus and the center of curvature both are in front of the mirror. In case of convex mirror, this is concave mirror. In case of convex mirror, the principal focus and the center of curvature, they are behind the mirror. Okay, again The distance between pole and the center of curvature, that is radius of curvature, as you know already, right? This is just related to the terms related to these spherical mirrors. What all we learned here: center of curvature, that is C, center of curvature. Next, F, principal focus, we learned principal focus. Next, we learned principal axis, we learned, and radius of curvature, we learned radius of curvature we learned. What is the pole? The radius of curvature, that is R, that is P means pole of the mirror, we learned mirror. Next, focal length, that is small f, it is focal length. These terms we have studied already, right? These are very much important. Once if you understand these terms, then further topics will become very much easy for you to understand. This is just terms related to the spherical mirrors, that is concave mirror and convex mirror. Now let us try to analyze how to represent the diagrams using ray diagrams, that we are going to learn in the next case. Now, in order to draw the ray diagrams for the images formed by the spherical mirrors, how to represent those images formed by these spherical mirrors using ray diagrams, that we are going to learn now. There are some set of rules. When a ray of light, when it is parallel, when it is passing through focus, how it moves, that is practically tested, and based on that some set of rules are made. According to that, we are drawing the ray diagrams. First, let us consider the first rule. The first rule says, for ray diagram, okay, rule 1, what it says here: if this is a concave mirror, you have to show the principal axis first, here pole, and this will be a center of curvature, and this will be principal focus, right? Let us call this as MN, the mirror. Now, if you consider a ray which is parallel to the principal axis, after reflection by a concave mirror, it passes through the principal focus. You have to show it like this. When it is parallel, it passes the principal focus, right? This is in case of concave mirror. If you come to the convex mirror, let us take the convex mirror. Rough surface I am showing one side. This is pole, this is principal focus, this is center of curvature will take. Now, a ray which is parallel to the principal axis, in case of convex mirror, a ray which is parallel to the principal axis, after reflection, it diverges. How it diverges? It appears to be diverging from a point on the principal axis. Okay, we call this as principal focus. Means what? If it is parallel, in case of convex mirror, if it is parallel, it appears to be diverging from the principal focus. In case of concave mirror, if it is parallel, it passes through what? Principal focus. This is first rule. Okay. Now, rule 2. Very simple. In rule 2, again, now this is concave mirror, this is pole, principal focus, this is center of curvature. Now you see, if a ray is parallel, it is passing through principal focus. Okay. If a ray is already passing through principal focus, after reflection, it should be parallel. It is moving parallelly. It is like this. What you are following one road to reach some places, some location, and there is no other way for that to come back to your original place. At that time, you need to follow the same path, right? Here also in the same way, if it is parallel, it is passing through principal focus. If it is already passing through the principal focus, it emerges parallel to the principal axis. In case of concave mirror, it is right. Now let us try to see this one. What happens in case of convex mirror? This is in case of concave mirror, right? Now in convex mirror, what happens here? A ray which is appearing to be passing through a principal focus, say here the ray, you have to show this behind the mirror with dotted lines, not continuous lines. It is appearing to be passing through the principal focus. After reflection, what happens? This emerges parallel to the principal axis. See, it is appearing to be passing through principal focus first. Okay, this is center of curvature. Now, here we can consider this. This we can take this as center of curvature. Here also, laws of reflection that holds good here also. That is, angle of incidence is equal to angle of reflection. Now, this we believe a ray which is appearing to be passing through the principal focus in case of convex mirror emerges parallel to the principal axis after reflection. This is second rule. Then what does the third rule say? Rule 3. What does it say? Here again, if you draw concave mirror, in case of concave mirror, this is F, this is C, right? Now in case of, this is center of curvature, right? A ray which is passing through the center of curvature in case of concave mirror, after reflection it follows the same path. Means it is not changing its direction. It is following the same path and returning back along the same path. When it is incident through center of curvature in case of concave mirror. What happens in case of what? Convex mirror then? That also we need to study here. This is pole, okay. This is principal focus, this is center of curvature. Now you see, a ray which is appearing to be passing through the center of curvature. See, this is C. Okay, will show here. This is C, exactly at the center F. Now, a ray which is appearing to be passing through the center of curvature in case of convex mirror follows the same path after reflection. Means how it is incident in the same direction it is returning. It is not changing its path at all, right? This is in case of convex mirror. Now let us go ahead to the rule 4. What does it say? That is last rule. Let us remove this one. Otherwise we will do in this place. I hope it will be visible to you all. Again, taking a concave mirror, we are considering rule 4 in this case. In rule 4, what happens? This is principal focus, this is center of curvature. A ray which is incident obliquely towards the pole in case of concave mirror, it emerges obliquely after reflection After reflection, it emerges obliquely following the laws of reflection. Following the laws of reflection means what? Angle of incidence is equal to the angle of reflection. Here, principal axis is considered as normal to this surface. Okay. If you consider any spherical surface, at each point you can find a normal there at each point. Okay. But here we are considering the principal axis. Okay. At the principal axis we are considering it as normal here, and it is making the same angle with this principal axis, that is incident ray, and here reflected ray also is making same angle with this principal axis. So angle of incidence is equal to angle of reflection, we can say, right? So we can say angle of incidence is equal to angle of reflection. It is obeying the laws of reflection here also. That is both the laws, that is incident ray, the normal at the point of incidence, and the reflected ray all lie in the same plane. That is also holding good. And both angles, that is incident angle of incidence and angle of reflection, both are same. That is also it is obeying there. This is fourth rule. And what happens this one in case of convex mirror? If you consider convex mirror, again it is pole here. Pole will show this side. Now a ray which is incident obliquely towards pole P, it emerges obliquely after reflection. After reflection, and it obeys the laws of reflection. That is angle of incidence is equal to angle of reflection, right? Okay. These are four set of rules. Means if you remember these rules properly, then very easily you can draw the ray diagrams for representation of images formed by the spherical mirrors.